Imagine slipping on a coat that instantly matches the snow-covered ground. Or maybe your skin flashing vibrant warnings to arrival. Picture your very appearance shifting with the sun's heat, like a built-in climate control system. For us, that's the stuff of science fiction, right? But for countless creatures across the globe, this is just everyday life. We've all heard of the chameleon, the poster child for color change, instantly making us think of it, blending seamlessly into a leafy background. Camouflage. That's the obvious answer, the one we all learned. But what if I told you that's just scratching the surface? Just one brushstroke in a much bigger, more amazing picture that evolution has painted. Animals transform their appearance for all sorts of surprising reasons that go way beyond simply hiding in plain sight. Today, we're exploring the vibrant, dynamic world of animal color change. We'll uncover the fascinating science that allows animals to become living mood rings, thermal regulators, and even masters of secret communication. You're going to be amazed, because the reasons animals change their color are as diverse and spectacular as the animal kingdom itself. Alright, let's start with the one we all know and love: camouflage. It's a classic survival strategy, and for good reason. In the relentless game of predator and prey, seeing without being seen is a huge advantage. And some animals have truly taken this to an art form, using color change to pull off the ultimate disappearing act. Consider the Arctic fox. As winter blankets its tundra home in a sea of white, the fox undergoes a pretty remarkable transformation. Its summer coat of brown or gray, which is perfect for blending with rocks and sparse vegetation, is shed. In its place grows a luxurious thick white fur, making it almost invisible against the snowy landscape. This isn't a quick change, mind you, it's a gradual process, cued by the shortening daylight hours and dropping temperatures, a careful adaptation to the rhythm of the seasons. This seasonal shift is mirrored by other creatures like the ptarmigan and the snowshoe hare, all donning their winter whites to either evade predators or ambush unsuspecting prey. The science behind this often involves the pineal gland, which responds to changing daylight by altering hormone production, ultimately affecting the pigments in their fur or feathers. But nature doesn't just do slow and steady. Some of the most breathtaking examples of camouflage happen in the blink of an eye. Enter the masters of rapid transformation. Cephalopods, cuttlefish, octopuses, and squid are the undisputed champions of instantaneous disguise. These speed merchants of adaptive coloration, as some have called them, can alter their skin's color, pattern, and even texture in as little as 200 milliseconds. That's faster than you can blink. Imagine trying to spot an octopus that has not only matched the color of a coral reef, but has also mimicked its very texture, complete with bumps and spikes. How do they do it? They achieve this incredible feat using specialized skin cells called chromatophores. Think of these as tiny, pigment-filled sacs in their skin. Millions of these chromatophores, containing pigments of yellow, red, brown, and black, can be individually controlled by the animal's brain and nervous system. By expanding or contracting these sacs, the animal can instantly reveal or conceal different colors, creating complex dynamic patterns that perfectly match their surroundings. The peacock flounder is another aquatic marvel, a flatfish that can settle on a complex seabed, and within seconds, its skin will display a pattern that makes it virtually indistinguishable from the sand, pebbles, or algae beneath it. The mimic octopus takes this even further, not just matching backgrounds, but also impersonating other, more dangerous sea creatures like venomous lionfish or sea snakes, a stunning display of defensive trickery. And it's not just about speed. Some animals, like certain shore crabs or the goldenrod crab spider, undertake a more gradual color change, taking days or even weeks to perfectly match a new environment. The goldenrod crab spider, for instance, can shift from white to yellow to better ambush pollinating insects on different colored flowers. It's a patient game of hide and seek, where the stakes are literally life and death. These incredible feats of camouflage really show the power of natural selection, honing these abilities to give animals a real edge to survive. Whether it's a slow seasonal shift or a lightning-fast transformation, the goal is the same: to become one with the environment, to fool the eyes of those who would do them harm, or those they intend to make a meal of. But as astonishing as camouflage is, it's only the first chapter in our story of animal color change. So if camouflage is about disappearing, then our next set of reasons is all about being seen, but often only by the right audience. Color change is a remarkably sophisticated language in the animal kingdom, a vibrant visual vocabulary used to convey all sorts of messages. Forget subtle body language. These animals are practically shouting their intentions from the rooftops, or rather, across their skin. The chameleon, while a camouflage expert, is perhaps even more renowned for using its color-shifting abilities for communication. Those spectacular displays of bright flashing colors aren't always about blending in. Often, they're broadcasting loud and clear messages to other chameleons. A male panther chameleon, for example, might show off an amazing array of intense reds, yellows, and blues to intimidate a rival during a territorial dispute, or to advertise his fitness and attract a female. Darker, more subdued colors might signal submission, stress, or illness. Scientists have discovered that these rapid changes in chameleons aren't solely due to the dispersion of pigments in chromatophore cells. They also involve an incredible layer of cells called iridophores, which contain nano-sized crystals. By actively changing the spacing between these crystals, chameleons can reflect different wavelengths of light, producing those brilliant structural colors. So when a chameleon turns a vibrant green, it might be because blue light is reflecting off these crystal layers and passing through an upper layer of yellow pigment cells. It's a complex, multi-layered system for sending precise visual signals. Cephalopods, our rapid camouflage champions, are also master communicators. Cuttlefish and squid engage in mesmerizing light shows, their skin pulsing with waves of color and intricate patterns. These displays are far from random, they are specific signals. A male Caribbean reef squid might display vibrant red patterns to woo a female, while simultaneously showing white on the other side of its body to repel a rival male. Talk about multitasking. Some squid species, like the Humboldt squid, are known for their dramatic flashing, thought to be a complex form of communication, though the exact words are still a mystery to us. These aren't just simple hello or goodbye messages. These visual signals can convey aggression, courtship readiness, warnings, and even information about their status within a group. An octopus might suddenly flash white with black around its eyes, to signal it feels threatened and might attack. It's not limited to reptiles and marine life either. While many birds are known for their fixed, vibrant plumage used in mating displays, some fish also use color change for social signaling. Certain fish species can intensify their colors during courtship rituals to attract mates, or during aggressive encounters to intimidate rivals. These changes might be driven by hormones and can occur relatively quickly, transforming a drab individual into a brightly colored spectacle. Even some insects and spiders use color change for communication, though often more slowly. The mantis shrimp, already famous for its powerful claws and incredible eyesight, can display bright colors to warn off rivals or attract mates. Their complex eyes can perceive polarized light, adding another layer to their visual communication that's invisible to us. This ability to broadcast messages through color is a vital tool. It allows animals to negotiate social hierarchies, find partners, and avoid unnecessary conflict, all without a single sound. It's a silent, vibrant language painted across their very beings, showcasing an entirely different and equally important reason for changing their colorful displays. So, animals change color to hide and to communicate. But the versatility of this incredible adaptation doesn't stop there. Imagine having built-in climate control, the ability to adjust your body's temperature simply by changing your outfit. For many ectothermic or cold-blooded animals, color change is a key way to manage their body heat in a constantly fluctuating environment. It's all about thermoregulation. Reptiles in particular are adept at using color to control their internal thermostat. Chameleons once again show their mastery. On a cool morning, a chameleon might darken its skin to a deep brown or even black. Darker colors are more efficient at absorbing solar radiation, allowing the chameleon to soak up the sun's warmth and raise its body temperature more quickly. As the day heats up, or if the chameleon needs to cool down, it can lighten its skin to a pale green or even whitish hue. Lighter colors reflect more sunlight, helping to prevent overheating. This isn't just a passive change, it's an active physiological response, triggered by temperature and light levels, allowing them to maintain their body temperature within an optimal range for activity and digestion. Bearded dragons are another fantastic example. They can change the color of specific body parts to manage heat. Their backs might darken significantly in cooler temperatures to absorb more heat, helping them reach their ideal body temperature of around 35 degrees Celsius, 95 degrees Fahrenheit, faster. This ability to quickly darken can save them valuable basking time, which in turn reduces their exposure to predators. Conversely, When hot, their backs can become a light yellow to reflect the sun's rays. Interestingly, while their back color changes significantly with temperature, their beard and chest colors are more often reserved for social signaling, changing dramatically during interactions with other lizards. This shows how an animal can even use color change on different body parts for different jobs at the same time. This thermoregulatory color change isn't exclusive to lizards. Many other reptiles and even some amphibians and fish exhibit similar behaviors. Pacific tree frogs, for example, might appear darker at cooler temperatures, which could help them absorb more warmth. For these animals, being the right color isn't just about looking good or hiding. It's about basic survival, ensuring their bodies can function optimally in their environment. The efficiency of this strategy is remarkable. A simple shift in skin tone can mean the difference between being sluggish and vulnerable on a cold day, or active and ready to face the world. Even for some mammals, while their primary insulation comes from fur, color can play a role, although it's often linked with seasonal changes that also serve camouflage. The Arctic fox's white winter coat, for instance, not only provides excellent camouflage, but is also incredibly thick and has superior insulating properties, with individual hairs having hollow shafts that trap air. While the main benefit here is insulation, the reflective nature of white fur might also play a subtle role in their overall thermal balance in the bright, snowy Arctic environment. However, for ectotherms that rely directly on external heat sources, the ability to actively change color provides a much more direct and dynamic way to manage their temperature. This ability to use color for thermoregulation really shows just how clever evolution can be. It's a simple, yet elegant solution to a fundamental biological challenge, allowing creatures to thrive in environments with fluctuating temperatures, all by using light and color. We've journeyed from the snowy Arctic to vibrant coral reefs, uncovering just some of the incredible reasons why animals change their color. It's a world far more complex and fascinating than just simple camouflage, isn't it? If your mind is buzzing with the wonders of the animal kingdom, and you're eager to explore more of nature's most ingenious adaptations, then make sure you hit that subscribe button. And don't forget to ring the notification bell so you won't miss our next adventure into the wild. We've got so much more to discover together. From the silent, deadly artistry of camouflage that allows a predator to stalk unseen or prey to vanish into thin air, to the flamboyant, expressive visual language that broadcasts mood, intent, and social status across a crowded reef or forest. And finally, to the subtle life-sustaining shifts in hue that allow a creature to bask efficiently in the sun's warmth or reflect its scorching rays. It's pretty clear that when an animal changes its color, there's often far more going on than meets the eye. The Arctic fox's seasonal wardrobe change, the cuttlefish's instantaneous patterning, the chameleon's emotional rainbow, and the bearded dragon's personal thermostat. These are not just isolated curiosities. They are amazing examples of evolution's creativity. These abilities are driven by sophisticated biological machinery, layers of specialized chromatophore cells packed with pigments, intricate arrays of light-reflecting nanocrystals, and complex neural and hormonal control systems, all working together to produce these dazzling transformations. Animals change color to survive, to communicate, and to thrive. It's a dynamic interplay of physics, chemistry, and biology, a constant conversation between an organism and its environment. So the next time you see an animal, whether it's the subtle shift of a fish in an aquarium or the dramatic display of a lizard in a nature documentary, remember what we've talked about. Remember that you're likely witnessing a complex and fascinating story unfolding, a vibrant display of adaptation honed over millions of years. The world is full of these colorful secrets, reminding us that nature is incredibly clever and often breathtakingly beautiful. There's always more to learn, always another layer to uncover in the amazing story of life on Earth.